Good afternoon, everyone. And today we are going to solve one question. In our previous class, we have discussed about the concept of boundary layer. That is very important. Whether a flow is a turbulent or laminar flowing over any object, whether it is a smooth flat plate or any surface, when come in contact with flowing fluid, there is a resistance from the surface. So what kind of the boundary layer created due to contact fluid with stationary surface of the plate, that we are going to discuss. Already we have discussed the concept of boundary layer. So we have derived boundary layer thickness and concept of displacement thickness, momentum thickness, energy thickness, shape factor, and how to define energy loss due to boundary. Because due to creation of boundary layer, there is a stagnated flow. Flow between boundary layer and surface is slowed down, and this stagnated fluid, due to this stagnation of fluid between boundary layer and surface, is slowed fluid flow, and it is displaced over the boundary layer, means shifted over the boundary layer. So how we numerically calculate boundary layer thickness, displacement thickness, and momentum thickness, energy thickness, and this question we will define how energy loss can be described in terms of the head loss, that is a loss in terms of the column of the height of the fluid. So this problem make you understand about concept of boundary layer thickness, momentum thickness, energy thickness, and how to calculate. Because once you understand concept, then you will easily solve the questions. This question is very good question. So first we will create question and then solve it. So let us write a question. So this is a question you see here. Work out the following boundary layer parameters for the velocity distribution u by u naught. U is a varying velocity at any point, any section. You can take from leading edge to any point along the surface. So u naught is a free stream velocity. It is a constant velocity, free stream velocity, where effect of surface is not effective. And y is a distance from the surface in vertical direction, and del is a boundary layer thickness. So this is relation, power is 1 by 7. So here we have to find out the displacement and momentum thickness and the shape factor. This shape factor equal to del star by theta. So we have to define shape. This h means shape factor. This is dimensionless number. And the second, energy thickness, and further evaluate the energy loss due to boundary layer. At a particular section, the boundary layer thickness is 3 centimeter, and the free stream velocity is given 12 meter per second, and the fluid discharge rate is 5 meter cube per second per meter width of the plate. This is a question, and so we have to solve this question. Now minimize it for reference purpose. So this is a question, and following let us recap formulas that are required for calculation. So first is a displacement thickness. This is defined as integration 0 to del and 1 minus u upon u naught dy. This is this equation for displacement thickness. Second one is a momentum thickness theta, integration 0 to del and u by u naught, 1 minus u by u naught, integration this is dy. And third, we have to calculate third one, that is a energy thickness. Energy thickness, that is equal to 0 to del u by u naught, 1 minus u by u by u naught to whole square dy. These are equation, and h equal to del star energy thickness upon momentum thickness. So these are parameters we have to find out. So first we define displacement thickness. This is a displacement thickness. So let us define displacement thickness. Del star equal to 0 to del integration 1 minus, now putting value of u by u naught. Here given u by u naught is given y by del to power 1 by 7. So putting this value, y by del to power 1 by 7 and dy. So this we have to calculate. So now equal to 0 to del and dy minus 1 upon del to power 1 by 7 y to power 1 by 7 dy. So integrating this one, we get y minus 1 upon del to power 1 by 7 into y to power 1 by 7 plus 1 upon 8 by 7. Whole limit will be 0 to del. That will be equal to del minus 7 by 8. If you calculate 7 by 8 del, you calculate it, we get y to power 8 by 7 minus into 7 by 8, and that is 1 upon del to power 1 by 7, and here we'll put limit 0 to del. So we get this value del minus 7 by 8 del. That is equal to this equation we get del by 8. So answer with del by 8. So first one is a del by 8. So del star equal to del by 8. This is first parameter. Del star equal to del by 8. Now second one, theta equal to 0 to del, integration 0 to del, and u by u naught 1 minus u by u naught dy. Putting values, because this is already defined, u by u naught equal to y upon del power 1 by 7. So now replacing this one. So putting all values here, 0 to del, and value will be equal to y upon del to power 1 by 7, 1 minus y upon del to power 1 by 7 dy. So take it inside. So first we simplify it, 0 to del, y upon del to power 1 by 7 minus y upon del to power 2 by 7, because it becomes square, and whole value integrated. So now simplifying it, 1 upon del to power 1 by 7 into y to power 1 by 7 dy minus 1 upon del to power 2 by 7 and y to power 2 by 7 dy. Integration 0 to del. So now that is equal to 1 upon del to power 1 by 7 into integration of this one equal to 7 plus 1 by 2, 8 by 7. 8 by 7 means 7 by 8 into y to power 8 by 7. 8 by 7, and limit will be equal to 0 to del minus 1 upon del to power 2 by 7 and y to power 10 by 7 into 7 by 10. Taking limit 0 to del. That will be equal to, here once again it will be equal to 7 by 8. Simplifying, we get 7 by 8 del minus 7 by 10. Simplify it, you get 2 by 7 will go up, and so 2 by 7, 10 minus 2 by 7, 8 by 7. Here 2 by 7 plus 1, 9 by, that will be 9 by 7. Simply it will be 9 by 7. This will be equal to 9 by 7, not because 7 plus 1 by plus 2 is 9 by 7. So 9 by 7 here, 9 by 7, so 7 by 9, not 7 by, that will be 7 by 9. 7 by 9. Simplify it. This will be equal to 7 by 8 del minus 7 by 9 del. That is equal to, we take 72 common, it is 37 minus 56 del. That is equal to 7 by 72. 7 by 72 del. This will be equal to 7 by 72 del. So theta equal to 7 by 72 del. This is a calculation of theta. That is a momentum thickness. Momentum thickness equal to 7 by 72 del. Let us check it. 7 by 72 del. Yes, it is 7 by 72 del. Now third one is, so now this replacing this one. Third one is we have to calculate energy thickness. Third one is energy thickness, because when there is a displacement of the fluid from the boundary, so there is a displacement of the mass flow or volume flow, displacement of, when mass is displaced over the boundary layer, then there is a momentum displacement. If there is a momentum displacement, then there is an energy displacement. Energy displacement will cause loss of energy within the boundary layer. So we have to also know what is the loss of energy within the boundary layer due to displacement of fluid over the boundary layer due to formation of the boundary layer when fluid is coming in contact with the surface. So third, we have to calculate energy thickness that is defined by del double star. This equation is equal to integration 0 to del u upon u naught 1 minus u by u naught whole square dy. So putting values u by u naught in terms of this given distribution, that is equal to 0 to del, and let us first multiply it by u upon u naught minus u upon u naught cube dy. That is equal to putting values 0 to del y by del to power 1 by 7 minus y by del to power, because it is square, so it becomes 3 by 7, and integrating it. So let us now integrate it, taking one constant terms outside. So 1 upon del to power 1 by 7 taking out, and y to power 1 by 7 dy 0 to del minus, let us integrate it first. So integrating y to power 1 by 7, so it becomes y to power 7 plus 1 8 by 7, 8 by 7 into taking 7 by 8 outside and taking limit 0 to del minus 1 upon del 3 to power 7, and integrating y to power 3 by 7, 7 plus 1, 7 plus 1, 7 equals 10 by 7. So y to power 10 by 7 into 7 by 10, 7 by 10 and 0 to del. So now simplifying it. Already limit we have put, so there is no need of putting this value because we have taken already limit. So now simplifying it, 7 by 8, that we simplify it, then it becomes on del only, because del to power 1 by 7 will go up and 8 minus 1, so it become, and 7 by 7, so become del. So 7 by 8 del, this is again minus here 7 by 10. Here you are saying 7 by 10, and del to power 10 by 7 minus 3 by 7, again 7 by 7, so it becomes del. That is equal to, common we can take common 40 and 35 minus 28 del. That is equal to 7 by 40 del. 7 by 40 del. So this is equal to 7 by 40 del. Del double star equal to 7 by 40 del. So all parameters we have calculated. Let us find out shape factor. What is shape factor? Now we have to calculate shape factor. What is shape factor? H equal to del displacement thickness upon momentum thickness. So displacement thickness we have del by 8 upon momentum thickness 7 by 72. 7 by 72. Del and del will be replaced. So 7 by 72. 7 by 7 del by 8. Sorry. So that is a del by 8 upon 7 by 72. 7 by 72 del. So del will be replaced. That will be equal to 72 by 56. 72 by 56, that is equal to 72 by 56. Let's calculate it. 72 by 56 equal to 1.28. 1.28. This is just 72 by 56. 72 by 56. So this is the dimensionless quantity shape factor, because it is a ratio of the displacement thickness to momentum thickness. That's why it is a one dimensionless number 1.28. Now coming to the second part of the question, energy thickness already we have calculated. Further evaluate energy loss due to boundary layer. Energy loss due to boundary layer. So how we calculate energy loss due to boundary layer? Because we have calculated. In this question we have given value given at particular section boundary layer thickness is 3 centimeters. So what will be energy thickness? So this energy thickness equal to we have calculated 7 by 40 del, that is 7 by, already we have calculated 7 by 40 del, that is equal to 7 by 40 into 3 centimeter, that is equal to 21 by 40, 0.525, 0.525 centimeter. That is a energy thickness. That is a energy thickness. So what is energy loss due to this thickness? So we have to find out loss in energy. Energy loss equal to mass 1 by 2 m into v u naught square. What is the displacement mass in this width of the? So we can calculate mass equal to 1 by 2 rho. So that is equal to 1 by 2 rho into thickness. We have not put it thickness, that is a del star that we have find into width of the plate. Width of the plate is given per meter, that is we will take 1, and velocity, that is u naught, and u naught is square. So this is a actual value, 1 by 2 rho del star into u naught q. That is a energy loss we can calculate by using this equation. So this is equal to 1 by 2 into 1.2 into 0.525 into 10 to the power minus 2, that was in centimeter, into 12 cube. So this value we get in terms of the energy loss. That is 0.5 into 1.2 into 0.525 into 10 to the power minus 2 into 12 to the power 3. 5.44 joule. This is loss in energy due to formation of boundary layer. This energy displaced beyond the boundary layer. This is concept. Because once we get energy thickness, so how much energy is flowing beyond the boundary layer, that we can calculate by using this equation. 1 by 2 rho naught means and energy thickness, and what is the width of the plate, that is 1, and velocity it make a volume, and rho it become a mass, and 1 by 2 mv square. Free stream velocity, because beyond boundary layer velocity is a free stream velocity. This is a energy loss due to formation of boundary layer, and this energy loss we have to express in terms of the head of the energy, head of the fluid. That is we know that energy equal to omega q into HL. That HL we have to find out. So HL loss equal to E upon omega q. E already we have calculated, 5.44 upon omega means rho q and rho g. This is rho g. Sorry, omega means rho g. Rho g and q. So 5.44 upon 1.2 into 9.81 into q, 5 meter cube per second. So this is a head loss, 5.44 upon 1.2 into 9.81 into 5 equal to 0.092 meter of the fluid, that is meter of the fluid column. This energy loss, 5.44 joule beyond boundary layer, is equivalent to 0.092 meter of the fluid column. That is a head loss. Either we can represent energy loss in terms of the quantity, 5.44 joule, or in terms of the fluid column, that is 0.092 meter means 92 millimeter, or 9.2 centimeter is a loss of the head. So this is all about how to solve question about boundary layer, and in our next lecture we will discuss some further details about boundary layer, turbulent flow, boundary layer, velocity distribution in smooth pipe, and also von Karman momentum equation. This is very interesting and important for you. For competitive examination purpose, it is important, and so this is enough for you for understanding concept of boundary layer and different parameters which are very important from condition point of view, boundary layer thickness, and then further topics are still remaining which are important. We will discuss in next lecture. Thank you very much, and have a nice day. Please like and subscribe and share it to your friends.